Hey everyone, welcome back. In the previous episode, we took a look at the mockq and xunit library, where we took a look that mockq can help us write tests without depending on other tests and other classes, so programming against interfaces, and xunit to test actual units of code. Now in today's episode, we're actually going to look at doing some TDD, and we're going to take Bob Martin's style of test-driven development, which is essentially the 3 laws that state you're not allowed to write any production code unless it is to make a failing unit test pass. So the only time you start writing production code is when a unit test starts failing. Next, you're not allowed to write any more of a unit test than is sufficient to fail, and compilation failures are failures. So when we started writing our unit test, you might imagine we might not have a function existing, or we might not have a class existing. It will not be long until our until our test starts failing due to compilation, and then we're going to have to write production code. Okay, and once we have the production code to stop the compilation failure, we're going to have to then reach the assertion state where our test will fail in an assert. So then once our test is failing from an assert, we can again write production code. And what the third rule states is you're not allowed to write any more production code than is sufficient to pass the one failing unit test. Now this rule is a little bit weird, but all it says is that do the minimal thing to make a unit test pass. And I'll bring some examples of this, but there is one slight condition where you want to sort of break this rule to accommodate another rule, is where your test gets specific, your production code is meant to get more generic. And sometimes doing the most simplest thing will make your code specific, and at that point you gotta make it more generic. But when we reach that, I will again bring it to the forefront. We're more or less familiar with these rules. I'm going to be reminding you of them as we're stepping through. Again, go ahead and read this article. I will leave a bunch of links in the description regarding test-driven development information, maybe some talks as well. If you want more information, leave a comment. But essentially, before we even start test-driven development, what I want to do is just say that test-driven development is not going to solve all your problems. It's not a silver bullet. It doesn't eradicate the need for thinking about architecture, having domain knowledge, and planning. You still need to do all of those things and know about what you're building, right? So architecture, if you're not thinking about what your system might look like, or the components that you need, or the layers, test-driven development is going to corner you and your project will fail. Domain knowledge, again, domain knowledge is it can be just as simple as doing a little test project to realize what you actually need for a voting system. Okay, so what we did in the first couple of episodes, we acquired a bit of domain knowledge, so we already know what kind of things and problems we can encounter and what we can expect to build. So in the first episode, we actually acquired some domain knowledge and some architectural knowledge in terms of knowing when to split it into components, and then planning. So during this test-driven development, we're going to plan. We're going to need a database, and we're going to think about where we're going to place this stuff. But if test-driven development doesn't solve all those problems, what does it do for us? The main point of test-driven development is that you can refactor afterwards. So anytime you write code, it's going to get messy. First time you write code, it is always a little bit messy. It's not refined. You haven't brought it to its best potential of readability or some other kind of mark that you measure how good your code is. And essentially, test-driven development eradicates the fear of changing code because you know that you're not going to break anything because your tests pass. And another thing I find test-driven development really useful in is that when you write a test, you sort of build a name up, you have the one thing you're working on, and it really keeps you focused. So if you're ever struggling with just trailing off into different tasks, you're like sort of building one thing, and it's like, oh wait, I need a database, and you start building a database, and then you forget what you were initially building. So it's good for those kind of things. So for me, it's really two things, and primarily test-driven development is for refactoring and being able to refactor so your code doesn't rot away, but it is also very good for focusing on a single task. But still, don't forget that ultimately you still need to be thinking about the big picture, like architecture, domain knowledge, and planning. And remember that you're allowed to refactor only when all tests are passing. So before we start writing tests, again, we're going to refresh ourselves on the domain knowledge of the voting system, and we're going to take a look at what we have in our program, right? So we know we're gonna have a counter, and we know we're gonna have something like a counter manager. We might not. These are the objects that we came up with while building it this way, right? What we should rather be looking at is the sort of the essence of what we have. We have a counter that sort of has a name and a count, and then all we want is to see some statistics about it. So we want to see the percentage of the counters, and there is something regarding this excess. We'll get to it, but not so important. So it's the most important part is we can identify the counter, we can see the count of the counter, and based on the count, we can see some sort of statistics and who won and what not. So let's go ahead and work from the fact that we have some sort of a counter with a name and we're trying to see some statistics. Let's go ahead and create a new counter tests. And by the way, the names during your test-driven development, they're probably going to change. So don't be afraid to just give it any old name. And once you get into it, you will start to realize more what you're sort of going to be testing or building. So let's create our first test. It's going to be a fact. Let's bring in an XUnit so we can start writing our test. Public void, and what should we do here? Let's start with the very first thing that we did is sort of when we had a counter, we gave it a name of yes and no. So the counter should be able to have a name in order for us to later display it. So let's go ahead and say counter has name. And the counter bit here is not really important because we already have the counter test there. So we can just say that has name. Okay, so let's go ahead and create a counter. And we are writing the test here first, as you'd imagine in test-driven development. And now we can see as soon as our test stops compiling, this is where the second rule starts to engage. So let's go ahead and generate the class. I'm going to press Alt-Enter and generate class in the same file. And the only thing I'm going to change is this internal to public, because if I would have written it from start, there's no need for me to make it internal, since later on I'm going to go ahead and try to move it out into a different file anyway. The constructor is also a bit unnecessary at this point, but at this time we have the test compiling, so it's sort of passing, so we're no longer failing the test because it doesn't compile. It compiles. We can now start writing the test again. Let's go ahead and create a name. We'll say counter name. Okay, and now we want to assert that the counter that we have created is going to have we're expecting this name to be on our counter name, right? So we don't have this name property. Let's go ahead and generate this field. And silly enough, Visual Studio is not too helpful, so let's go ahead and rename this to string, public string get name, and I would like it to be a property. Another way we could have achieved this name if we would have done something along the lines of counter name equals, and then at this point it would have stopped compiling. We would have to generate this field and assign the name here. So essentially the counter has the name counter name, right? So let's go ahead to our test explorer, and I'm actually going to pin it here. The voting system, the math1 and test1 tests are going to get a little bit in the way. So what I'm actually going to do is I'm going to delete the unit test1. You can keep them for reference. I will delete them. So let's go ahead and run these. So just to state my opinion, these kind of tests are a little bit unnecessary in reality. However, when you're starting off, it is okay to just write these sort of unnecessary tests just to get your foot for the door. Like the first thing to do, just to get you started, it is okay to write tests like these. Later on, as you gain more experience, you'll just have more idea of what you're doing, and thinking about the goal that you're trying to reach will be a little bit more easier, as you're not preoccupied with learning how to write tests, right? So you got to realize if you know how to write code and you're learning test-driven development, you're actually struggling to write code because you're learning test-driven development, not because you don't know how to write code, okay? So, moving on. Our counter has name, and that's alright, but primarily the goal of this voting system, again, we're going to return to the bigger part, is once we have multiple counters, we don't really get a lot from one counter on its own. The counter exists in an ecosystem of counters, right? that's what the whole voting process is. The voting process is multiple options and being able to vote for those options and then being able to show the information, right? So the counter on its own here doesn't really do much for us. A voting system is an ecosystem of counters in a category where we can vote for stuff. So this is where I'm going to start writing tests for getting counter statistics, okay? And I'm going to start with public void get counter statistics, and I'm going to say that it includes the name of the counter, right? Because this can be a nice way to identify a counter in a human readable way, and then an identifier can be made to make it identify for a computer. But for now, I'm just going to say when I'm going to be displaying my counters, I want to display the name as well, right? So includes counter name. And here again, I'm going to create this counter. I'm going to take this counter name. And again, I'm going to assign the name to the counter. And now what I'm going to do is grab the counter statistics, right? Counter statistics is the information about the counter in regards to other counters. So for us, it will be that counter's distinction in terms of its name and its percentage compared to other counters. So if you remember previously, all we needed is a total, but we'll come to that. So let's go ahead and create a function get counter statistics. Get counter statistics. Okay, so we don't compile. Let's generate a method. And the one thing that I want to return here doesn't really matter that much. Let's go ahead and run the tests. It will throw because this is not implemented. So all we actually need to do is kind of like make it void. But we're actually assigning something here. So we can go as far as returning an integer. So this is the second rule where we're kind of like, sorry, the third rule. We're just doing the minimal thing we need to make the test pass. Now we're going to go ahead and try to assert, because the test is essentially saying that we expect the statistics to include the counter name, right? But the long-term goal of this statistics is to actually display the percentage, the count, the information about the counter regarding to the other counters, okay? So here I'm just going to assert that, again, these are going to be equal. So the name and statistics dot name are going to be equal. And all I really need to do here to pass this is just make this return a counter. I'll return this here. And again, if I would have run the test there, it would have compiled and failed here, but now I changed the type that it's returning, and I'm just returning the same thing, right? So one thing we can make here is actually, let's remove the counter here. Now that all our tests are passing, we're going to do a little bit of refactoring. I'm going to remove the counter names because this is sort of on the counter and we're just getting the statistics, right? So let's go ahead and run this. Cool, everything's still passing. Another bit of duplication is we have here. So let's go ahead and clean this up. What I'm going to do is I'll just bring in the counter to the top here. So public counter equals new counter. And let's make a counter, just like that. And we can also make public const string counter name equals, let's put this here. Let's remove this. In the constructor here, we can specify the name. I will rename this name to actually be coherent, like name and name. Okay, and remove all of that, since now I can specify the counter name in the name part and counter right here. Okay, and then I can do the same thing, kind of the same thing here, but specify this here and counter name at the top here. And I'm going to remove this constructor since I don't really need it. Okay, let's run the tests. Cool, everything's still passing. Another thing you can do if you want to is you can make a static import on the assert class. So what we would have to do is, let's copy this xUnit statement, and we're going to say using static, and we'll have to navigate to this class. Oh, not that, assert. And now what we can do is remove the assert here, and now we just end up with an equal function and all the other functions that assert provides. Now that we sort of got our foot in the door, then we sort of again got back to the actual big picture and thought about the problem, and we realized that the counter is not going to be in its own thing. It's going to be comparing to all these other counters. We write a test that sort of sets us in a direction where we get the statistics for the counter. You can name this get information, get counter information, whatever is feeling right to you. For me, it's get statistics. And now I'm also going to remember that counters need a count, right? So let's go ahead and I'm going to say that the statistics will also include the counter count. Okay, I'm just going to go ahead, copy this code, and includes counter. I'm going to rename this to count. And instead of counter name, I'm just going to say something like 5. And for statistics, I'm going to say 5 here. And it's not going to compile, so I'm going to have to generate a variable, and it's going to be a property. And instead of an enumerable object, I am going to use my brain to actually change this to an integer so it compiles. So let's go ahead and run this. Okay, so it's failing because our actual integer is 0 and we expect a 5 because we're not actually passing a 5 anywhere. And what I can actually do is just go ahead, grab the count here and pass the 5 here. All right, why 5? Just a random number. That doesn't really matter. Okay, so all the tests are passing. We have a name for the counter and we have the count for the counter. That was pretty much the base things we need for the counter. Let's go ahead and actually work on deriving the percentage, etc. And to actually be able to have percentage for the counters, what do we need? Other counters. Correct. If you thought that, good job. If you didn't, still good job for sticking out through this video. Don't forget to like if you're enjoying it so far, or leave the video if you hate it. Don't forget to leave a comment if you hate it. But let's keep going. So public void, and again, we're going to work with the same method for get statistics, because this is what it's going to get. This is why this method exists in the first place, is to sort of display statistics for the counter. So get statistics, we'll say shows percentage based on total count. Okay, so let's go again, grab our statistics, we can do it from here, and we are going to say equal. All right, so at this point we still have only one counter, but that doesn't really matter. We don't need a second counter because our test depends on a total count, right? And this is kind of the same thing that was happening in our program CS. We didn't actually need to know all about all the other counters to actually know the percentage that this counter occupies. We only need to supply the total count. So this is what I'm going to do here. So because the default count is sort of 5, I'm going to go ahead and supply 10 to get that nice 50%. Okay, and well, before I actually write that, this does not compile. Let's go ahead and make this compile. We'll say total count. Okay, and here we will need to supply something. Okay, so let's go ahead and just supply the default count because that's sort of 5. Okay, so again, let's change this to 50, and statistics, we'll get percent here. So let's go ahead and generate this variable, and we'll generate a property. And again, an enumerable object, not the best. We can make it an int so far. Okay, and the easiest thing we can do to make it pass so far is percent equals 50. Okay, we're not really utilizing the total count, but based on Uncle Bob's third rule is essentially don't write any more of the unit test of the production code that is essentially sufficient to pass. So we're going to do the bare minimum thing. Okay, so everything's passing. Now, knowing that essentially this is not correct, this percent thing is obviously not correct. We're statically setting it, we're not deriving it. And this is where I said, if you watched the beginning of the video, this is where I said that the third rule, it has its application, but it will also have its own deviation where it's sort of it does apply up until a certain point where you start breaking another rule, where your production code is meant to be getting more generic instead of being more specific. So what do I mean by that? This unit test is being very specific in terms of, right, we're going to supply total count of 10 with a base count of 5, and we're going to get 50, okay? And this is just going to say, right, I'm just going to give you 50, okay? Let's go ahead and change this unit test because we will need a little bit more here. And what I'm going to do is I'm going to provide some inline data for, let's say, the base count, the count that this counter should have, the total count, and then the sort of expected percentage. I'm not actually going to type the expected, but let's go ahead and say count, total, and int expected. Again, before we know, having the domain knowledge, we know that we're going to aim for the decimal place. We know that this should be a double. You are allowed to utilize as much of your brain power as you want to actually go ahead and make this a double from the get-go, like that. Nothing is constraining you, right? You're allowed to do that. I'm just going to go ahead and start with this for now. So I'm going to grab the counter and I'm going to put the count on here. I'm also going to put the total here. Right, so for the counter I need to actually set it to the count property. Okay, and now the expected value, let's go ahead and pop it here. So after modifying this test here, it's still passing. Now what this allows us to do is add a little bit more to these tests, right? So let's go ahead and actually do something along the lines of 1 out of 3, which I know will give me something like 3 and 6 on the end, and this is where I actually wanted to round up to 33.33. And this is where I know that this int is not going to cut it. I'm going to convert this to a double. And this is where I also know that if this is a double and it's comparing it to this int, this will never cut it. But we can actually go ahead and, what's it called? Check it here, right? So we have a failing test, which is this 33, and we're returning 50, right? So again, I'm going to return to this point of the third rule where we need to write the bare minimum. And you following that rule blindly, what you can end up doing is something along the lines of, all right, well, when we're checking for 10, we'll get a 50, right? So let's go ahead and say total count. If that equals 10, we can just return 50. Or sorry, we can go ahead and set 50. And else if total count is equal 3, this is when we set the 33.3. Okay, so let's go ahead and do that. And we're going to do this. And this, obviously, we can't assign this because this is an integer, so let's put this to a double. All right, let's go ahead and run this. Okay, and this passes. This is working code, but again, this is a specific solution. This is, again, if you watch the first episode, accidentally open Internet Explorer. If you watch the first episode, you'll remember how instead of having where is it? Sort of these like generic things that we want to perform with the counters, we had massive if statements that map out every single solution, right? So that's the difference between genericism, being generic, and writing specific code, right? So following that third rule blindly can lead you into believing that you should be writing this kind of code in a test-driven development. This is not true. The third rule is trampled by your production code, which is this production code, should be growing in a generic direction. As your tests get more specific, your production code should be getting more generic, right? So if you're being specific in terms of these, like 2, 4, or let's make it 8, and this should be 25%, And again, all you're going to do is add something like this, where you're going to see if total count is 8, 25, and we're going to run it. Okay, this is not correct. Sort of, as your test grows more specific, your function is equally more specific. This is where you actually need to break this loop of being silly and actually appease the other rule. Your production code needs to become more generic, okay? So this is where we start to utilize our brain power, okay? We're going to go ahead, remove this. We're going to go ahead and say that the count, I'm going to divide it by the total count, and as before, I'm going to multiply it by a double, okay? And I'm actually not returning this, so I will have to grab the percent here and assign it to the percent. I'm still returning this here. Okay, let's go ahead and run this. Okay, so the two tests pass. The one thing that doesn't pass is where we need to round up, and again, we already know how to do the rounding up. Math.round. And again, my rule, I want it to 2 decimal places. I specified it right here. So that's where it is. Let's run this. Okay, and let's make another test just for the heck of it, that we know that it rounds up to a correct number. So like if it's 2 out of 3, it's going to be like 6. So I want it to round up, not down, kind of thing, right? I want to make sure it's rounding up at the correct place. So I'm just going to run that as well. So we got percentage. What we can actually do is, because this says shows percentage based on total count, we can say shows percentage up to 2 decimals based on total count, right? So we are specifying in our test that this should be up to 2 decimal places. Now, this is where we come up to the problem of adding the excess to one of the percentages, right, of one of the counters. This is where we have to have knowledge about the percentage from all the counters. So what we'll have to do is create some sort of a function that will grab all the counters, and it will then know what to do. So let's start again with the easiest. What should happen if everything draws, right? And again, it's just going to be the 333.33 scenario for 3 counters, okay? So let's go ahead and do something like that. For the fact, public void resolve excess, okay? Resolve excess doesn't add excess when all counters are equal, okay? So yeah, when all counters are equal, we're not gonna add excess. Okay, so what was the test condition? We wanted the percentage to be equal, right? So var counter1 equals new counter, and the name doesn't really matter for this. Count is 1 and percent is 33.33. Okay, and we're gonna create a couple of these. We want to resolve excess, and what essentially should happen is, let's just say resolve excess, the function, just like that, and let's generate this method, and it's just going to be right here. We can stick it on the counter. It's part of the test suite right now, so what's probably a good idea is just make a public class, and we'll call it counter manager right now. I know this compiles already, but I'm using my brain cells to put it here, okay? And what I'm going to do is say new counter manager resolve excess, and this is not private, this is public. Void, did I misspell it? Oh, silly me, forgot to call the constructor. Okay, and actually it's probably going to be a little bit easier if this was static, but again, I'm just going to stress the point of make a compile, and then let's get the test passing. So again, it's not implemented. We can actually just remove this to make it pass for now. Okay, so once it's passing, let's go ahead and say that assert that equal And what we're doing is searching that the excess is not getting added on, right? So counter 1 percentage, and that's actually 33.33. And we're checking counter 2, counter 3. Remove this assert here. Okay, let's run this. Cool. So we didn't actually need to pass anything here, but I'm gonna just say, because I kind of like trailed off and broke a couple of rules, I'm not gonna punish myself and do something along the lines of this. I'm gonna say that what I actually wanted to do is I wanted to pass a list of counters here. Let's go ahead and create a counters equals new list of counter, and I'm gonna populate it with counter 1, counter 2, counter 3, just like that, and pass my counters here. Okay, and I'm just gonna grab this type so I can pop it here. I put counters here. Okay, so let's go ahead and run this. Okay, it's passing. Good. Now let's go into a condition where the excess gets added on to the winner. Now I'm just gonna go ahead and write this out. Let's go ahead and say fact before we start thinking about the test. Public void resolve excess, and we're gonna say adds excess to highest counter. Okay, so for this example, I'm just gonna have 2 counters. Again, I'm just gonna be able. I just want to be able to create a list of counters. No, we're not gonna have the 3rd counter, and the count itself doesn't matter. All I would like to do is indicate the winning one. And let's say that the rounding up has gone south on this 1st counter, right? So there is just going to be that 0.01 excess that I'm simulating in this test, and I'm just specifying to which counter I'm expecting it to be added on. Okay, so let's go ahead and assert equal 66.67 on counter 1%. And for the second one, well, I'm expecting this to not be added actually. 33.33. I actually forgot to call my counter manager, resolve excess, counters. Nice. Okay, so let's run this. Okay, so it's failing. Obviously, we're not adding anything. So the easiest thing we can do is, again, because we know the position of this counter 1, right? It's in the position 1. So what we could do is, why is this not counters? We can grab the first one, we can grab the percent, and we can do this. Okay? And this is okay-ish, but we actually break the previous test. So I guess this kind of 3rd rule, you can see that our previous test actually catches that exception, that we can't just add that on. So this is where tests start to get actually quite fun, because you get to utilize some of your brain. So if you want to pause here and try to implement some of this to get this test passing, go ahead and do that. Otherwise, you can watch me do it. So I'm just going to do the same thing I did previously. I'm just going to go ahead and grab the highest percent. I'm going to grab the max, grab the link, grab the percent. And what I'm going to do is I'm going to say if, and before actually, if I need to grab these, highest counters equal counters where highest percent equals highest percent. I'm just going to cast to list because I don't want it to enumerate multiple times. So I'm going to grab the highest counters. I'm going to grab the count. And as long as it does not, or actually, yeah, as long as it's less than counters dot count, I'm going to grab the highest percent. As long as the counters that I get, the highest counters, because it's the highest percent, the highest counters. If the highest counters are less than the counters that I have, then I want to do something with regarding assigning the percentage, because otherwise it's just the ultimate draw. It's well, this ultimate draw, right? We don't want, that's the only condition. When everything's equal, we don't want to assign the excess. So this essentially, I'm filtering out the ultimate draw condition. Here, what I'm going to do is I'm going to be stupid. Okay, and what was it? Not quite. Okay, there we go. Go ahead and try this. Nice. Okay, good. And again, knowing that we have just done that, and we know that this is not a correct solution, let's go ahead and try and write a test that breaks this. So what we could do is something along the lines of copy this whole test, somewhere here, remove these vars, and edit the values here, like swap them around or something like that. I'm actually not going to do that. What I'm going to opt in for is just going for a different condition, a different test, because I kind of know that that will help me weed it out. So let's go ahead and write another fact, because there are other types of conditions we can get, like adding stuff onto the smallest counter, right? So let's go ahead and say void resolve excess adds excess to lowest counter when more than one winning. No, these are highest counters here. Highest counters. Okay. Let's copy this. Pop this here. Pop this here. And I'll say something like 221. For this, I will say that this is 44, 44. Same thing, 44, 44. And this would have to be, if this together is 8, 11, 11, and it would have to be added on like so. Okay, so this is the condition here. Obviously, I don't actually think, if I bring out the calculator, 2 divided by 5, 0.4, so you see it rounds up, but I don't really care about that. All I care is the recognition of the highest counter and the fact that it will do the percentage thing for me. The rest of it, let's grab the setup here. Counter is 3. And by the way, if you haven't noticed, this is a thing that people teach. I'm not sure why this is not like apparent. For these small tests, you essentially, I'm just going for the equals. So the assert section, and usually you have the act and the sort of setup, act, assert. So where you do the setup for the test, where you do whatever your functionality needs to be. This is sort of the setup, so we can move it up here. We can move this one up here as well. And as well, we do the action, and we assert. And here as well, we can move the setup up here. So whatever information you need, you do the setup, then you execute the functionality that you're testing, and then you want to assert to make sure that your test pass, or that your functionality works as expected. For the counters, let's go ahead and grab our asserts here. Let's pop them here. We'll have to grab one more. Let's grab the 44. Pop it here, and for this, I'm expecting it to be like so. And let's change the number 3 here. Let's run this. Cool. So it breaks. We are actually adding it on to the first one, to the first counter, so that doesn't work. We honestly don't want to do that. This condition is actually occurring. We want to do the addition to the first one when it's indeed the highest one, right? So what I'm going to do is I'm just going to go ahead and type equals here, and I'm going to separate the if statement out a little bit, right? So, and oh, sorry, the count actually. I wanted to change this to 0 because I want this to happen only when we have one highest counter, and change this to 1. Sorry, talking and writing is hard. So if the highest counter is 1, this is the only time that I want to do this. Otherwise, as long as the highest counters are not as big as the counter count, I want to grab the lowest counter, and that's when I actually want to attach it. And again, I'm not going to be stupid like I was here. I'm just going to leave this as an example of being stupid, and we're going to try to tackle this. Here, I'm just going to go ahead and do something similar to what I did here. So let's say lowest percent counters min percent of our lowest counters, or let's say lowest counter. So counters where, and we can say first stop percent equals lowest percent. Yeah, that's all we need, and we don't actually need to grab it. For the first one, we can just say percent plus equals 0.01. Okay, so we got this. Let's go ahead and run this. Okay, everything's passing. Really nice. For some reason, I'm actually surprised we're not running into this double issue where when we're adding the 0.001, we're getting the double point precision error. But nevertheless, I will consider this lucky and hopefully it will not pop up. I will add another example where resolve access doesn't add access when the percentage is 100, right? That's actually when we don't need to add access. So let's go ahead and copy this test where we have a lower amount, and let's just do something simple. And something a little bit more realistic. So 20, this will be 80, this will be 20. Counter 1, counter, and we'll call this resolve access doesn't add access if total percent is 100. Okay, so total percent is 100 here, so this is what I'm expecting it to be, not actually adding anything on. So let's go ahead and run this. Obviously we'll fail. Cool, this is failing, we're adding it on, and this is where I'm just going to go ahead and say if counters sum, yeah, I want to add up all these percents, and if they're 100, let's just return. I'm not going to do anything. Okay, cool, so it's all passing. So let's go ahead and solve this in terms of adding the 0.01 and 0.01 here. I'll first tackle this top bit in terms of adding it on when we have a winning counter. Since again this test is not actually bound to the count specific, it's actually bound to the percent. And I think the count, do we actually use the count here? No, the count here is only to check the count of the collection. So the count isn't really important. I will, however, leave it there. The main resolve access is actually getting off the percent, and after we write this test a little bit more, I will refactor it out. Okay, so let's change this to a theory and inline data. So what can we control? The setup for the highest, the setup for the lowest, and then expected for the highest and expected for the lowest. Okay, so there's 4 things. So let's say expected highest, or let's do 67, or rather 66 and 66.67, the other way around. So if I can write the correct numbers, what we provide, what we expect, and for the other one, what we provide and what we expect. And really, this shouldn't change, okay? Because we are checking the addition for the highest one, and the lowest one should never change, okay? Let's go ahead and say double initial, double expected, and double lowest. So let's say lowest here. Lowest will stay here. This is going to be expected, and this is going to be initial. Okay, so let's first make sure this passes. Okay, so a couple of interesting things we can do here is, let's say we actually decrease this by 1 more. We're going to get an extra % here. Okay, we didn't encounter this scenario before, but we might encounter it here, right? Who knows? And we do end up with getting a failing test. It seems to be trying to add the 0.01, and again, you can see that we're actually running into this error with the addition not being correct. And I'm actually being a little bit silly. This should actually remain 67 because these two add up 100. And if we take away 1 from this, this just means that this function will have to add it on. Let's go here, and what is happening? So we will need to add 0.02 instead of 0.01. So at this point, we will actually need to calculate the excess. So let's grab this total % that we have here and put it up here. So if total percentage is 100, I don't care, right? Otherwise, let's grab our excess, total %, and we know we're meant to be working somewhere to 100. Let's reduce this here, and excess, let's go ahead and add it. Okay, and it's passing, cool. Another thing I would like to do is, let's say we're in a situation where this is 66. However, this is 32. So this will have to be 68. Okay. I'm just curious as to what will happen. And it's passing. Okay. So now that all our tests are passing, what I'm actually going to do for these resolve access tests, I'm just going to remove the count here because, as we discussed previously, it's not actually needed. Let's delete this, delete this, delete this. Cool. Let's run this, and now it's all passing. Nice. Now, do we actually need anything else in terms of this solution? Now, I've actually forgotten about the condition of this 0.01, so let's go ahead to the function that tests the addition to the lowest percentage right here. Now let's go ahead and set something up similar to this. I'm going to go ahead, make this a theory, and let's just grab 1. And whoop, we can do something similar to lowest initial, and then there'd be the expected, and then there is the highest equal ones. Okay, so let's say double initial, double expected, double highest. So 3 variables, let's go ahead, put them in their place. So highest, they will go in this 44. This will be the initial one. And highest again, we want to put it here. And then this is the expected one. So first of all, let's run everything and make sure that everything is passing. Cool. Now let's go ahead and change this to be 10. And again, this is something that should be handled and added. Okay, and here we actually have a test failing because of this condition. So let's go ahead and fix it. And again, the fix, we already have it. We just have to grab this excess and put it on here. Okay, and now we are actually facing this issue with the double point precision failure. I'm not sure why did this actually set it off. Mysteries of programming, eh? So what I'm actually going to do, I want to sort of grab this, but I don't want to duplicate this functionality. I can put it as a round to 2 function on the counter manager and use it from this class. So it seems to me in the future, something to do with this, the way we get statistics, it might be moved to the counter manager anyway. Since this seems to be the data model, and the % part of it seems to be the more of a view model type thing that we derive, I think it will be wise to actually put it here. So let's go ahead and do that. Let's say public double static, public static double, I will grab the meth round and round to 2, or do we? We'll just say it as a de facto way of rounding up. Let's say double number, and this is the number that we're going to provide here. Okay, so round 2, if it's de facto, we should say round up. Let's go ahead and say counter manager round up and remove the comma 2 here. I'm breaking a few rules here, but I'm gonna be honest, I think it should be alright. Professional's choice, professional's decision, you know. Right, this is the lowest counter. Let's actually assign it to a variable now, because we will need the percent and the assignment. Alright, so we need to grab it from a place in memory. Right. Okay, so lowest counter dot percent will equal round up lowest counter dot percent plus excess. And of course, to be safe, we could do the same thing here. And I've just noticed that we're still doing this grab from 0th place here. Okay, so we'll tackle this in a second, but let's just make sure that this passes first. Okay, so all tests are passing. Now let's go ahead and handle this 0 position, right? Because we know that's the wrong solution. The moment it's the highest percentage is going to be at a different point. So let's go ahead and take a look at the test where we are checking this condition. Where is it? This is the one. Now I think the easiest thing to do here is just to set some sort of a flag, so to either set it first or second, and to preserve this sort of addition of numbers. So yeah, just a little flag to sort of indicate that no matter the order. Or we can be specific and say counters will we will need to copy about this much. We will need to override the counters because we will need to override their positions here, and we'll have to resolve the excess again. However, the one problem here is that these counters will have their excess already resolved here, so there is some state here. So we'll actually need to remake our counters here. So let's go ahead and do that. Counter 3 and 4. 3 and 4. Cool. Let's go ahead and run this. Okay, so we have a failing test. All of them are failing, and again, the reason they're all failing is because it's trying to add it to the wrong counter. One thing I'll do here is I'll rename the test because this is no longer suitable for this test. Actually, no, never mind. I was gonna say adds access to highest counter, ignoring order, but highest counter already implies that no order is involved. Essentially, the flaw is within this function right here. Okay, so there's no need to change the name. I'll leave it as is, and the test is actually looking fine. So the easiest fix here is grab the highest counters, grab the first, because there is going to be only one highest counter, and we add the excess onto it. Cool. So we are still getting the failures, and I am wondering why. Maybe it's something I did in my test. Okay. So I have just forgotten to rename these counters. So initial highest should be last, counter 4 should be first. Now let's run the tests. Okay, and all the tests are passing. Well, let's take a look at what we got so far. It seems like we did end up with a counter object that has this function. It seems like it could be placed a little bit better. And we have this counter manager. And again, it seems like a very similar solution to what we got in our sandbox project. We have the counter manager and we have the counter. I think the naming parts are mostly just domain knowledge being shared. Architecture side of it, not too much architectural decisions have been made. They're to be made yet. But in terms of the functions that we got, I think it's pretty interesting that we haven't actually been announcing stuff, but you can see that the announcement that we're doing here, the calculation of an addition of the excess and the calculation of the winner, is intertwined. They're essentially mixed up with each other. So this is a little bit interesting, because if we would have carried on to try to display the announcement type thing that we're doing here, it would have been as a separate function on the counter manager. So we would have actually gotten two functions, and the second function here that would have been called after with the announcement. So the two functionalities would have been separated. Another thing that I'm actually foreseeing that's going to happen, this percent thing, as I've said before, is going to move on to this view model object. And primarily this percent thing, we are kind of storing it in state here, but it's accidental state. And what I mean by accidental state is this can always be derived. It's always derived from count and total count, right? So we could pre-calculate it and optimize performance in terms of recalculating, saving the recalculation again. But that is what is known as accidental complexity, right? We can just recalculate it again. But not gonna ramble about that too much. It would be better if you tell me in the comments which solution do you think you prefer more, the one that we got from TDD or the one that we got from building it up step by step. But yeah, this will be it for this episode. Thanks for watching. If you enjoyed it, leave a like, subscribe. If you have any questions, leave them in the comments section. I know TDD can be a hard topic, and just to start your first test can be really hard, so don't be afraid to write silly tests like has name. And by the way, don't forget to check the description for more learning material. Don't forget to join the Discord server. It's also a good place to get in touch and ask questions. Hopefully, I'll see you in my other videos.